Hey everyone, happy 4th of July week. As you can see, we don't have our regular synchronous class meeting this week, but I have posted some work on Google Classroom for us to work on independently on the week of 4th of July. It's basically a little introduction to polyatomic ions. It's a very easy lesson, and then there's also a packet underneath that that reviews the work that we did the first two lessons, just so we can reinforce what we've already learned. So you guys are doing it correctly. You're watching my video first, right now. After this, I'm going to give a brief introduction on polyatomic ions, and then after that, there's another quick little video that I linked in the document that gives you some memory tricks to memorize these polyatomic ions. And then after that, you'll see is the long packet with all the practice problems from the first 2 weeks. So without further ado, let me just talk about what polyatomic ions are. So basically, what we've talked about so far is ions, and we learned that ions, if you remember from our very first lesson, are atoms that have gained or lost an electron. Therefore, they're charged. They're either positive or negative, and some of them have bigger charges like -2, -3, or +2, +3. However, when it comes to polyatomic ions, what we have is we have a bunch of atoms that are stuck together. And all of these atoms stuck together have the following charge above. So if you look here, you have PO4 -3. You have one phosphate stuck to 4 oxygens, and the whole thing here has a charge of -3. So I know what you're thinking right now. You said on lesson 1 that when you have a bunch of atoms stuck together in a molecule, the charges have to cancel. And of course, the exception to that is polyatomic ions. Polyatomic ions, when these atoms are stuck together, whether it be in this one or this one or this one, the charge does not cancel to 0. And the reason is because of organic chemistry, the way that the electrons and the bonds work and flow together. And we don't have to worry about that now. But for the purposes of general chemistry, and unfortunately for the purpose of AP chemistry, you guys have to memorize all of the polyatomic ions. And that's the purpose of the next video after this that I linked. Gives you some neat little memory tricks to memorize it so you don't have to memorize it cold. And I will probably insert a list that Miss Powell gave us with the polyatomic ions. All right? And one last thing I want to do before I go is I want to show you guys how to do the crisscross method using polyatomic ions. So let's say we have, and I'm hoping we remember the crisscross method. We did it on day 1. But basically it's how do we write the formulas when two things stick together. So let's say we have Na, charge on Na is +1, and we want to bind it to CrO4, -2. This whole thing is one ion, because this whole thing is stuck together. Chromate, I believe that's what it's called. So what we do is, we treat the whole polyatomic ion. This is the polyatomic ion. This is the polyatomic ion. This is just the ion. It's just good old sodium that we pulled straight off the table and turned into an ion. We treat this whole thing as one unit. So this whole thing right here has a -2 charge. So we just stick with our old rule for crisscross. We write the positive, we write the negative, we write the charge on both of them, and then we simply just crisscross them. We bring that 1 down here, bring that 2 down here. So now we have Na, and the 2 came down from that chromate, and then we have CrO4, and then for the purposes of staying neat, we usually put this in parentheses once we crisscross, just to let people know that this stays as one unit. That's the 1 down there. But for simplicity's sake, we could leave out that 1. All right? Let me show you guys how to reverse crisscross, which means we have the compound, we want to break it back up. So let's say we have Li3PO4. And so we have a lithium and then a phosphate. This whole thing is a polyatomic ion, it's phosphate. So what happens is, this here is started as an ion, just as lithium. This whole thing is a polyatomic ion. If we look on our list of polyatomics, it actually looks like this. This whole thing was phosphate. It's all bunched together. So what we do is we stick with our normal rule for the reverse crisscross method to break it up, and we treat this polyatomic as one unit. You keep the whole thing together, you don't break it up. So now we write the numbers in, the subscript, and we reverse crisscross them as usual. So then lithium gets a 3 on it. Oh, sorry, no. Lithium gets a 1 on it, because we bring the 1 down up. And then phosphate, PO4, gets a 3 on it, because this 3 came up. We look at the periodic table, and we look at the charge. We see lithium has a +1 charge. Phosphate, polyatomic ion, has a -3 charge. And then we're almost done, but remember we have to make sure we end with the same number of atoms. So we look here, we have 1 phosphate unit, but we have 3 lithiums to start with, so we have to throw in the number 3 there. That's how we crisscross it. Notice the P and the oxygen still stay together. Okay, let me just make a quick point real quick here. So do you remember how we said after we crisscross something, we normally put it in parentheses, put the polyatomic ion in parentheses? Here we don't have to. After we break it back up into ions, we could, for simplicity's sake, PO4 put in parentheses to specify that this whole thing has a charge of -3, but normally it's just understood when you have a polyatomic ion like this. So you don't need to put the parentheses here. So that's how we do the crisscross method with polyatomic ions. I hope this video helped. The next video that I linked in the document is gonna bring you to another video that's gonna give you some neat memory tricks when it comes to memorizing these polyatomics, just so we're not memorizing them cold. There are a couple of tricks that help us remember them. And after that is when you see the worksheet that I posted. I know it's a long worksheet for this week, but it really helps us reinforce practicing those math techniques that we learned the first 2 lessons, which will help us in the long run when we move forward. Other than that, I hope you guys enjoy your 4th of July week. Take some time off, take some time for yourself, and we'll see you next week.